Hi! This instructional video is another series of simplifying the rational expressions, and this time we're going to deal with adding and subtracting rational expressions with like denominators. Like denominators. Let's look at number 1. Oh, they are not like denominators, but that's an easy fix. Community property says x plus 4 is the same as 4 plus x. So why don't I fix that right now before I get started? There we go. Fortunately, there were no negatives here, so it's still the same. Now, when you're adding and subtracting fractions back in elementary school, you had to make sure that the denominators were the same. In this case, yes. And if they're the same, you add the numerators to become, in this case, 7 over 3. Same thing here. Do these two quotients have the same denominator? Yeah. X plus 4, x plus 4. All we do is then add the numerators. Unfortunately here, these two are not the like terms. So all we can do is go 5x plus 20 over x plus 4. But wait. Does 5x and 20 have something in common? Do they share a same factor? And you say, yeah, they're both divisible by 5. So yeah, let's factor out the 5. Then what you get is x plus, well, 5 times 4 is 20. And whoa, look at that. There's already an x plus 4 on the bottom. So the identical binomials, they can simplify. So your final answer is 5. Nice. You tried that spicy one over here. Alright. So you said, that's not fair. But it should work out. Look at this. First of all, do these two quotients have a same denominator? 3x squared minus x minus 2? Yes. So let's write that as one expression, common denominator, 3x squared minus x minus 2. And let's put the numerator with the minus. So 4x minus dx. Oh, wait a minute. Woo! You know what? This was a little spicy. That was a little tricky. There's a chili pepper. Why is that, you say? Because look, that's a minus. When you have a minus between the two quotients, this is like saying minus the quantity of x minus 2. And when you put it together, this is the way it should look like, right? But when you write the expression at the top without the parentheses, you have to make sure you apply the distributive property. So it becomes 4x minus x and plus 2. The signs inside the parentheses change. Phew, that was a tricky one. And now you combine the like terms, you end up with 3x plus the 2 over 3x squared minus x minus 2. Not very exciting, is it? Can this be factors, though? Let's see. What times what is 3? It's 1 and 3. What times what is 2? 1 and 2. Can those two numbers be mixed and matched to multiply? And if you add them, become a negative 1? Let's see. 3 times 1 is 3. 1 times 2 is 2. If the 3 is negative and 2 is positive, wouldn't that become a negative 1? And 3 times negative 1? 1 times positive 2, negative 1 times positive 2 is negative. We could factor this. This actually becomes 3x squared. 3x plus 2 on top. And the bottom, that's factorable as 1x and 3x. Those are always the x terms. 3 multiplies with 1. So 1 has to come over here, minus 1, and plus 2 over here. And look at this. 3x, 2 on the bottom, cancels out the 3x plus 2 on top. What remains is 1 over x minus 1. Oh, sorry to do that to you guys. But that was a good one. So then, if you could do that, then you try numbers 3 and 4. Alright, you said, hey, same denominators. So I could go ahead and write as a common denominator, x plus 1 on the bottom, and the top, oh, whew, this time it's just a plus. So I could write it as one expression, 4 plus 2x minus a 2. Now I can combine the like term. So 2x, well, nothing was going on there. However, 4 minus 2 is just plus 2 over x plus 1. And you realize, hey, 2x and a 2, they share a common factor of 2. So let's divide that out by factor it out. 2 times x is 2x. 2 times plus 1 is plus 2 over x plus 1. And, oh, again, x plus 1 cancels out, leaving you with a simple answer of 2. May your life work things out the way this works out. All right, number 4. So in this case, even though it looks complicated, they both have a same denominator, x squared minus 9. So let's write that as a common denominator, x squared minus the 9. And on the top, oh, look at that, it's a minus. And remember, it's minus 3x plus 1. And when it's a minus, you have to make sure you apply the distributive property. So you get x minus 3x. But it's not plus 1, it's a minus 1 now. Over x squared minus the 9. Now let's take care of this simultaneously. Let's combine the like term here. First of all, minus 3x. Minus 3x. Here, let's make it easier. Here we go. We have x minus 3x minus 1. And let's factor the bottom because we know that's a special product property. What times what is x squared? X and x. What times what is negative 9? Plus 3 minus 3. Now that we know, let's go ahead and combine the like terms on the top. Let's see. X minus 3x is minus 2x. And minus 1. Nothing's going on here. That was kind of boring. Oh well. And we should not have a negative coefficient when we have a binomial. It's a common courtesy to get rid of that. So let's go and take that out by going negative 1 times 2x plus the 1 over x plus 3, x minus 3. Okay? It didn't look any prettier, but there it is. Alright?